Thank you everyone for coming. It's the third day, just before lunch, so I thought I would try to pick something a little bit entertaining, and we'll try to make it also a little bit interactive to make sure everyone stays awake. So, bugs. So no, that's not the right kind of bug. Okay, we're getting closer. So that's the original computer bug. So from 1949. So we have now 75 years of bug history. So the ones we're going to talk about will be less physical and more pure software-based. So why this talk? So I've been doing professional C++ development for close to 8 years now, and as the dear creator of our favorite language said, C++, it's harder to shoot yourself in the foot, but when you do, you blow off your whole leg. So show of hand, who can relate to this saying? Okay, good. So these are all bugs that I've experienced firsthand in our code base. And you will see I'm not mad about them. I think we can learn a lot from these bugs about system designs, about how we can improve our practices. And for some of them, I will offer some mitigation strategies. For some of them, just meh. Oh yeah, so now is the time to reference this talk. So this is also one of the reasons I'm doing this talk. So for those who haven't seen it, I highly recommend this one. It's quite old now, but it's still very relevant to the C++ ecosystem. And so the bugs are closer than you think. So this might be you're happily developing, maybe you're using your favorite framework, maybe you're using Juice. And this is the sort of stuff that the Juice developers have to do. Get error message if init failed, or if it's a buggy didn't driver, which returns true from init even when it fails. Nice, love that. So we'll see there's quite a lot of that. And no system's perfect. This is also a way for everyone to feel a bit better about themselves. You will see that some of the big players also write some pretty nasty stuff. All right, so without further ado, bug number 1. So I call this one a variation of a classic. So let's say we've got some number of speakers, and this is real code from L-Acoustics, so I've condensed it for the slides purposes, but this is a real thing we had. So we have some speakers and we have some reverb channels, and the number of reverb channels is equal to the number of speaker channels, but it's capped to a maximum, right? And then we've got this array, which uses this constant, so it's capped to the maximum number of reverb channels. And then we have some form of loop, right? And we have this channel bin counter that we increment, right? And so the goal is we want to fill this array element by element. And then when we go to the number of reverb channels, we go back to index 0, right? So we increment and we use the modulo operator here. And then here I've just done an increment of this something variable for the example. So who can tell me what can happen with this line of code? Anyone raise their hand? Nope. No? Okay. So there's another mathematical operation that you need to be careful of that can lead to nasty things. Because so you've got the plus operator, the minus operator, the multiply operator. These you don't really need to be careful about. But division you need to be careful about, right? And what's a modulo? It's the remainder of a division. So there is a division here. And if the number of reverb channels happens to be 0, because we have no speakers, we have a divide by 0. So pro tip, when you look for code, when you're doing code reviews and you look for division by 0, the modulo is also a division. And so who can tell me what happens in C++ when we have a divide by 0 with integer numbers? Okay, in practice, so it's undefined behavior. According to the standard, it's undefined behavior, so nobody can tell you. In practice, what happens on most platforms?
0.
Okay, gives you 0. So I've just done a little test, and I want to make sure that the division by 0 is actually executed. So I've got these two helper functions, which are in a separate translation unit. And let's run it and see what happens. And indeed, we get 0. So for our actual case, that wouldn't be so big of a deal, right? Because we were accessing this array at element 0, which exists. So that would be fine. But actually, that's on ARM64. And if you do the same thing on Intel, and actually I'm running this on an Apple Silicon machine, but with an Intel build via Rosetta 2, you do the same thing and you get a hardware exception, right? So on x86, the ALU in the CPU will say, no, can't do that. And then hardware error goes back to your kernel and your program crashes. So props to the Apple guys, actually, who did that, because they made sure that Intel programs running via Rosetta 2 on ARM machines would behave the same as if they were running on Intel CPUs. And I imagine that was quite an amount of work to make sure this would behave this way. And so the problem is we're all developing on very nice Mac machines, but we also target Windows, where Intel is more prevalent. We also target Linux, and everything's fine on my machine, but it crashes for others. All right, bug number 2. The devil is in the details. So let's say you have a knob, and you want to use that knob to control some audio parameter. I think something quite common we've all seen. So some little helper function, so we'll be doing some dB to linear conversion and linear to dB. And I've got also half pi constant, so I'm using, I think that's C++20 STD numbers to get pi. And then we have our knob value, and this get knob value is supposed to return something between 0 and 1. Again, quite a common pattern that we see with plugin automation. And I really want to make sure I don't trust this function, right? So I really want to make sure it's between 0 and 1, so I clamp it with std clamp, right? And then I compute a gain by putting the knob value in a cosine function. So the kind of mapping we're looking for is something that looks like this. And then we go into, so this is a linear gain, we convert this into dB, and then we do some transformations. And this is code we had to map a legacy parameter to a new parameter when we redesign some of our algorithms. And then so we use this new value, we convert it back from linear to decibels, from decibels to linear, and then we set a gain in the model. So can anyone see anything that could go wrong here? Yes?
Log of 0 is minus infinity.
Log of 0 is minus infinity, right. But so we're clamping the value of the knob between 0 and 1, and the cosine of half pi times 1 is exactly 0, right? You're right. And so actually, it's a little bit trickier than this, because if you're in floating points, the cosine of exactly half pi, well, exactly half pi, as with the resolution you can get in floating point, is very slightly negative, which is really annoying. So you don't get minus infinity, you actually get not a number, our favorite. If you do it with double, actually it's very slightly positive, so you run out, so you avoid that issue. So float, right? Like, so anytime you do any math and you take the output of some function and you give it to another function which is defined on a subdomain of the real numbers, clamp, 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 clamp. And also you should potentially also check if it's not a number, because std clamp of not a number will return you not a number. All right, bug number 3. What's your full name? Oh yeah, that one's quite nice. So let's say we have some library to avoid name clashes in C++. We have this very nice feature called namespaces that we should all be using, right? So we have a lib and it has a header and it's its namespace. It defines some form of class. And then they do something that maybe they shouldn't do. In the header, they put using namespace lib. And dear sponsor of this conference, Juice, used to do that by default with producer-generated projects. So in my team, we have a very large code base which uses Juice, and we still have this because the pain of adding Juice : everywhere is something we're not ready to tackle yet. And then, so, okay, you use this library, so you're in your own organization, so maybe you have a namespace for your organization and then sub-namespaces for specific areas. And you create a class which derives from this class from this library. And crucially, you don't need to fully qualify the name of that base class because we have this using namespace lib, right? And then we use it. And so in this example, the base class has just an integer in it. So if we take the size of the derived class, ints usually 4 bytes, so we get 4. Okay, cool. So until now, everything's fine. So as a reminder, that's what we have already currently defined. And then you continue working. Maybe it's 5 years later. Maybe it's a different developer. And in another file of your code base, in the org namespace, you define another class, also named base, right? And then someone, for some reason, decides to include this header before the other header. And so the question is, what is the size of this now? First, okay, actually, rewind. First question, does this compile? If it compiles, does it compile with warnings? Someone at the back?
I believe the modules will compile, but not link.
So that's not technically correct. So the answer was it compiles but not link. No, it compiles with no warnings, even with all of those. And it links just fine because the full name of all these symbols are different, right? They're all in separate namespaces. There's no duplicate symbol issue. And the problem is, if you include this org header above the foo header, when you inherit from base in foo.h, now it decides to pick org base instead of lib base. And so now, if my org base is a different class, I get this. And the problem you have with this is by just naively including a header or changing the include order because maybe someone decided to add claim tidy and claim tidy decided to neatly organize all the headers, suddenly you get horrible crashes because some translations units will have one definition of the class and some translation units which don't include the header in the same order will think that this class inherits from the other one. And if you have virtual classes with vtables, like you get horrible crashes that are extremely hard to track down. So ban using namespace, that's the reason. And maybe compiler vendors could give us some warnings about namespace shadowing. At the moment, it doesn't seem to be a thing. All right, bug number 4, results may vary. Oh yes, so that one's quite good. So this was in some of our networking libraries. So we have like a send function, and we don't really know what kind of container will be used to pass a buffer to this function which sends something over the network. So we use a quite C-style API with a char pointer for the data, the size, and then a lambda for a callback. And this send is actually, so I've said it's asynchronous, it actually happens on the side thread, right? We have a separate network thread. So it will capture all of this and then actually do the send and then call the callback to tell the initial caller whether the send was successful or not. And so in our main, we could have something a little bit like this. So in our case, we decided to use a vector for the buffer and we call send like this. And so the crucial thing is the lifetime of that buffer needs to remain until the send actually happens. And one way of achieving this is to capture the buffer in the lambda because we're guaranteed that the callback lifetime extends until after the send happens. And we can debate about whether this is good API design or not. It was done like this for maximum flexibility and performance because then the caller is in full control of the buffer they're using. They can reuse a buffer from one send to another if that's an optimization they would want to do. Or they can avoid to do that if they want to do so. And so the question is what happens? And if you compile this with GCC and MSVC, what it prints is data size 0, which is not good. It means nothing has actually been sent. But if you do it on Clang, you get data size 3, and it actually works. Again, Mac users compiling with Xcode, Apple toolchain, Clang-based, then moved maybe to a Linux toolchain with GCC or MSVC, and suddenly it stops working. And so the reason why that happens is because in C++, the evaluation order of function parameters is undefined. So compilers are free to evaluate function parameter in whatever order they want. So if you have something like that looks like this, 3 functions ABC, they're called by a function. You need to call them before being able to call this function A. Clang calls them left to right, and GCC and MSVC seem to call them right to left. And by the way, like a great tool to check these things is Godbolt's Compiler Explorer. If you don't know that tool, check it out. And so the problem is this move operation here GCC and MSVC will construct the lambda first, and to construct the lambda, they need to evaluate the capture parameters of the lambda, so they will do this move first. And what this means is, by the time buffer.data gets called and buffer.size gets called, the data has been moved into this new temporary vector called data, and the original buffer is now empty. Whereas on Clang, we'll call this last. And in that case, it works perfectly fine because we get the pointer, we get the size, then we transfer, using the move semantics, we transfer the ownership of that buffer to something else. It doesn't move into memory, so the pointer remains valid, and it works. And so that's a good time also to plug this talk, Move from Objects in C++, where the speaker in that talk argues that the move semantics in C++ are a bit broken and that maybe it shouldn't behave like this. So highly recommend that one. All right, bug number 5, this is my favorite. This will blow your mind. So I have an application, very basic thing. So again, this is a toy example, but we saw that in our product. Juice application derives from juice timers. We have a timer callback every half a second, and we just print something in the console, increment that counter. So I'm going to run this, and you're going to see. So I run the program, and it works just fine. And then on the same machine, I'm going to restart the network configuration. So it's a Linux system, so systemctl restart systemd network D. And so it's still working, it's still running fine, but wait for it. Crucially, it's not immediate, right? Because that would be too easy. I think we're close now. It just stops working. And so you're like, what? Like, what? This is not supposed to happen. And so actually, after understanding what actually happens in our machine, when we restarted the network configuration, if we didn't have internet access, and we give internet access to the machine, maybe by setting a DNS server, then the network time protocol daemon in that Linux system starts up, realizes that the machine is at the wrong time, maybe it's a little bit ahead in the future, and sets the time backward. And so that's actually one layer down the reason of that problem. And some people have complained about this on JuiceFrom already in July 2018. And Jules was like, that doesn't seem really possible. Like, we do everything right by using the monotonic clock, which is guaranteed to continuously increment over time and should not be sensitive to system time variation. And so I'm like, yeah, but I still see that problem, so like I'm skeptical. So you dig into the code and you look in juice timer and it calls this get millisecond counter. And then you get into this get millisecond counter and you see this, which seems a little bit more complicated than it should be. So you're like, oh, that looks a little bit weird. And there's a big comment, which is a little bit smelly. But actually, though, that code's fine. So you dig a little bit deeper and you go, so that then it calls this juice system stats milliseconds in startup, which calls this thing, and that's why it calls the clock get time, like the C POSIX API to get the time, and it does call it with the monotonic clock argument. And you can put like a print in here, like a debug statement, and you will see it will continue to grow over time. It is not sensitive to system time. So at that point, you're like a little bit like, what, like you're out of things to try, right? But then we realized in our app that we were seeing the same thing for threads that do like periodic work like this, right? So I have a thread, and it does something, waits 500 milliseconds, and those would also wait for way more than 500 milliseconds. And it turns out that the juice timer under the hood needs a thread to keep track of when timers need to be firing, and it's actually that thread that wasn't firing. And so it's the same problem. And so you start looking at how this wait is implemented, and it uses this STD condition variable it calls wait for, seems to be doing nothing strange. So you look at the documentation, and you're like, okay, wait for, it takes a duration. Yeah, makes sense. And it says, okay, it's equivalent to calling wait until now plus the duration, right? And crucially here, it uses the steady clock. So like, okay, that's fine. And then you look at wait until, and you see that the clock, this is actually templated. You can actually use whatever clock you want. And then, so that starts to be a little bit fishy because you're like, oh, okay, I could give it like a system time. And then you look at the notes, and that's where things are not nice. There are no guarantees regarding the behavior of this function if the clock is adjusted discontinuously, But existing implementations convert abstract from system clock and delegate to POSIX, blah, blah, blah. So basically, the standard says there's no guarantee that waiting for 500 milliseconds, we wait for 500 milliseconds, which seems crazy. And so there's a reason for this is the C++ standard tries to be a little bit too smart. So the way you implement this in C, actually, with the pthread API, you need to actually choose the clock you're going to use for your condition variable when you create it. And then you can't specify this, but the C++ standard, you create the condition variable, and then when you call wait until, you can pick the clock. And that's the fundamental problem here, is that what the C++ standard says is not really implementable with the POSIX API. And so some people have known about this since 2009. This is a C++ 11 feature. In 2009, they already knew about it. And so looks like we should do it differently. Monotonic clock seems like a good idea. Chris, can you have a look at this issue? So by the way, I don't know these people, but they all work on compiler, standardization, STL stuff. Chris, are you here? And this is where like, yes, I'm alive. Okay, good. Starting to get back into the GCC swings of things. Okay, good, right, cool. So like, again, as relevant as ever. And this tiny thing might be something as important as the standard library of the compiler used to compile all Linux systems. So that's good to know. And then like long discussions, blah, 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 okay. Some people are arguing as we do. So this is already like a couple days later. But okay, at least we agree. In almost every project I've worked on, our purpose would be much better served if a monotonic clock were used instead. Rarely do we care what the epoch is. What we do care about is timer reliability, even when NTP or some other mechanism is changing the clock. Yes, thank you. Who has ever written, like, I want this thread to wake up at like midnight in 2 days? No, never. You always want, it's always like 1 second, 10 seconds, 500 milliseconds. And so fast forward 10 years, only took 10 years. They added the API to be able to choose the clock you want to use when you called pthread conwait and not when you create this condition variable object. And so it got fixed in GCC 10, but sadly Debian 10, which we were using at the time in 2021, shipped with GCC 8, and glibc, which was released, which was compiled just a few months before these fixes. And so Debian systems were affected by this until the Debian 11 release, which I believe was around 2021 or 2022, something like this. So more than 10 years, this C++ 11 feature was basically unusable. And I think the craziest thing is our application was the only thing affected in our entire system. All the other applications on that Linux system weren't affected, meaning C++ adoption in the open source world is not that big. So yes, so people on the internet were very happy about that. Hopefully that's been worth the wait. Yeah, coworker might actually run into this problem. That's one crazy thing most wouldn't have been aware of. It was so difficult to diagnose. I ran into this a couple weeks ago at work. Whoa, I thought we were the only ones with this bug. And we run into this in our embedded system as well. All right, so we're gonna tame it down a little bit now. So question is, when does life end? Question we all ask ourselves, I think. So in C++, because a very nice feature of the language, right, is that the order and construction and destruction of object is defined by the standard, and so we can use destructors to do useful things. And that's a pattern we called RAII. And Juice has this nice thing called a scope value setter. You give it a reference to a variable, and then you give it a value to set when this object is constructed, and then a value to set when this object goes out of scope. And this can be used, it's mostly used for reentrant functions where you want to bail out if this is a reentrant call. It's very often used for that, to protect these kinds of sections. But with this code, it doesn't do what you think it does. Who can tell me what the bug is here? Yes?
It is the hard to parse.
Yes, so we're getting close. So people said you didn't create a variable, and I heard it's the declaration of a function. So we're quite close to the truth. So we did create a variable. It's just a temporary, right? It's an unnamed variable. So and the function declaration knows this is a variation of this one that will come about later. So this is not ambiguous, right? So when you do this, you just, so we can validate this, right, with a simple object like this. So same kind of API, right? 2 parameters, and when you do this, you just call the constructor. It's an unnamed temporary, so it immediately goes out of scope. So you get constructor, then destructor, and then the thing you wanted to protect. So it doesn't achieve what you wanted to achieve. And the way to do it is you need to give it a name. And once it has a name, then it goes out of scope at the end of the scope, and then you get the result that you want. And this is a variation of a very classic bug using unit lock with std mutex like this. If you do this and you don't give it a name, you're not actually locking your mutex. And this comes from this curiously recurring bugs at Facebook. So if you do this, same thing, doesn't work. But the thing is, this actually warns if you use the set of warnings I've shown earlier, which should definitely use W all, W extra, W pedantic. It tells us unnecessary parentheses in declaration, because this is interpreted as a declaration of a variable called mutex. It's telling you about this vexing parse issue. This is something that, this is this ambiguous parsing thing, but the standard says that it should be interpreted as a declaration. And also we have shadowing, right? Because now we have, instead of passing mutex as an argument to the unique-log constructor, we're creating a new variable called mutex, which shadows the mutex you're actually trying to log. So if you have warnings, you'll see that. But for this, there's no warning at all, with the exact same set of warnings. So yeah, I have no solution for this apart from code reviews. Maybe static analyzers could help, but yeah, otherwise I don't have any solution. It doesn't have a name, so it's not unused. This has side effects, right? So this could be something you want to do. Like a constructor is like any function. Maybe you just want to call a constructor. Maybe that constructor does something useful. And so in a similar vibe, this one I have called API design. So Juice has this nice class called results. And so we have this do something function which returns a juice result, and then we call it, and we call if do something.ok. Anyone familiar with juice result can see the bug here. Nope. Okay. Ah, yes. You want to call is okay. Yes, okay. Create and return a successful result. If you write it like this, you will always take the branch. Again, good luck to catch that in a code review. Like this looks fine. So the one you want is was okay, or actually probably the better way is this cast to bool. So actually just remove this, it casts to bool. And you can't, so thankfully you can't do the same thing with the fail, because to create a fail result, you have to provide an error message. So in that case, you wouldn't be able to get into that issue. All right, bug number 8, really remember, oh yes. So let's say we have some form of like container and we can insert a value. It's some form of like settings thing. So the values are actually juice vars so that we can store strings and different integers, booleans, different kinds of types, right? And we have a version where we care about the order. So we have an insert index, and then we have an overload where we don't have this insert index, just puts it at the end because we don't care, right? And so you've got something which returns a size t. And then you're going to call it like this. So insert value, compute something, and you want to insert it at, let's say, index 3. This doesn't compile, and it doesn't compile because there is no constructor for juice var that takes a size t. All the constructor takes signed types. Size t is unsigned. And so so they call it an ambiguous conversion. Basically, the compiler doesn't know if it should which constructor it should call, if it should call the int1 or the int64 one. So you fix this by adding a cast, right? So you do this. Okay, cool. Does anyone, so a couple questions. So there's something wrong with that code. So does this compile? If you think it compiles, does it compile with warnings, again, with that same set of warning as before? Anyone? Comma operator. Comma operator, okay, so you guys know the thing. So yes, it compiles without warning. And what it actually does is it constructs a juice var with value 3 and calls the second overload with no warnings, again, at all. And so for those who don't know about the comma operator, evaluate expression A, disregard this return value, complete any side effects, then evaluate expression B. And so if a function like static cast only takes one argument, you can actually give it it looks like you're giving it more arguments. So it looks like you should get a compile error because it doesn't find a function with that signature. No, it's fine. It will just call compute something, discard the result, and then pass 3 to the static cast. So, and obviously what we wanted to do is we needed to have the parentheses here. Again, this compiles without any warning whatsoever. Funnily enough, if you were to write it this way, then you do get a warning because the val has no side effects and its results is unused. There's really no reason you might want to write that. But for some reason, the compiler people think that you may want to write it like this. You really want this compute something to be evaluated at this exact point and have these size effects evaluated without caring about the result. So actually here, maybe unused attribute on compute something could be helpful. If it's a pure function, it doesn't have any side effects and its sole purpose is to return you a value. Maybe unused, I think here would help you. Sorry, no discard, and then you would get an unused no discard. So a reason why the comma operator may be used if you want to do like wacky loops like this works. You can use the comma operator. Some people don't agree with that though, so that one's quite hilarious. That guy wanted to make his code readable, so it's like, 10,000, that's a big number. It's hard to read the number of zeros. And C++ indeed lets you break large constants, large literals, but it's with the apostrophe, and they thought it was the comma. And by doing this, cool, your loop now loops from 0 to 0, so your loop suddenly becomes a no-op. Again, with no warnings. Although, like, you can't do things like this. If you want to do things like this, you have to do it like this, which kind of looks like ugly. And again, I don't really know why you want to do anything like that. And finally, before we come to a close, we have this very nice 3D view in our software to show the speaker layout. And to do 3D graphics, often you need to do quite a lot of matrix math. And for this, we use the GLM library. And we were on like a fairly old version from 2017. At some point, like, okay, we need to update it. Like, what could go wrong? We go from 0.9.8.5 to 1.0.1. This doesn't seem that far off. And like, how can matrix math change, right? Like, matrix math is a defined thing. Actually, it turns out everything can go wrong. This is what happened when we did that, just a black screen. And again, so now you have like thousands of lines of 3D rendering code, and you have to understand like where the math goes wrong. And so actually, we had a lot of code that looked like this, like identity matrix with the empty curly braces, default constructor. And we realized this wasn't the identity matrix anymore. And in old versions, they used to do that. And so crucially, the default was that it would init it to an identity matrix. And then in the following versions, they give you now two options. You can either do it with initializer list or in constructors, but the crucial thing is both of these compile flags default to false, right? Both of these expressions evaluate to false by default. So by default, your matrices are now filled with zeros instead of ones on the diagonal. And they put this in improvements. No more default initialization of vector matrix in quaternion time. So you do a search in the changelog for like breaking changes, like maybe there's something we miss. No, improvements. I disagree with that. Should be breaking changes. So again, like, why do they consider this improvements? There is a reason. If you look at the spec of GLM, they are supposed to provide an implementation in C++ which matches the OpenGL shader language specification. And the GLSL spec says if there's a single scalar parameter, it's used to initialize the diagonal. If there's, and in our case, there was nothing here, right? So that's not the case. So everything else should be initialized to 0. And that's why they considered it an improvement. But again, like, it would have been nice to mention it in a breaking change things. And I think that's all I have for you today. Thank you, and enjoy your...
Thank you, Olivier.